Okay, let's look through this few exercise as an exercise on the how to use a normal distribution table. The first one, number 12, ask what is to find the area under the standard normal curve between z equals 0 and z equals 0.55. So the first thing we do, I will draw a normal curve to indicate the region. So in the middle, we say that's our mean. And as mean, I'm going to label with a standard normal, which should be 0, right? We say that means how many standard deviation from the mean to the mean is going to be none, which is 0. And then where is the 0.55 is going to be bigger than 0, so we're going to just put it to the right side of 0. And it says between 0, z equals 0, and between z equals 0 and the 0.55, which will be right here. And then we're going to go to the table to look up 0.55 as z-score. Here is a corresponding area. And the meaning of this table, again, all the a values will be the area under the curve between z equals 0 and the positive z. So that means 0.209 answers the question. The area is going to be 0.209. And the next one, between 0 and a negative 2.05 as a z-score. So we are going to do a normal curve. And again, in the middle, that's the mean. And the negative 2.05 is going to be to the left of the mean as a negative z-score. We're looking for the area between these two z-scores. Now notice in the normal distribution table, there's no negative value. So therefore, we're going to make use of the property of a symmetry of our normal curve. So the question here is, if I can find the area between 0 to positive 2.05 as A, then we say this will share the same value because this is a symmetric curve. So we're going to go to the table, find 2.05. 2.05 as a z-score here will be the A value, and the A value is going to be 0.480. So we say the area right here is going to be 0.480. Okay, let's look at the next one. Next one, it says to the right of z equals 0.25. To the right of z equals 0.25. And again, this is the middle. We mark it with a 0 as a z-score. 0.25 is bigger than 0 as a positive value, so we put it to the right side of 0. It says to the right of this z-score, so that's how we shade. This is called, this region, shaded region, is called to the right side of 0.25. So we're going to go to the table. 0.25 as a z-score is right here. And this will be the corresponding A value. Now, if I were to mark this within the diagram, where should I put it? Again, remind yourself, all these A values as the area between z equals 0 and the positive z. So z equals 0 and the positive z, so the area of 0.099 should be here. So in this blank area, okay, right here. But that's not my question. My question is the shaded region. So there we recall, to one side of the mean, the curve contains 50% of the data, or the area is 0.5. So 0.5 subtract this region will give you shaded region. So we use 0.5 subtract 0.099, and that's going to give us 0.401 as the area of the shaded region. And the next one, we look at number 18. And number 18 says to the left of z equals negative z-score. So again, I draw a normal curve and I locate the middle, and negative must be to the left of 0 of the mean. And it says I need to find the area to the left of this z-score to the left. That's how we shade. And this is a negative z-score. Again, from the table, there's no negative z value, and then we're going to use the property of a symmetry of a normal curve to answer this question again. So we said if I can use 1.45 from the normal table, that's right here, and I have a 0.427. The meaning of a 0.427 is the area between z equals 0 and the positive z. So this is a 0.427 if I were to label in here. So it will be this region, right? And then by the property of a symmetry, that I get to know this must be 0.427. So therefore, this region, again, we recall half of the normal curve contains 50% of the data value, or the area as 0.5. So if I know part of it, I can know the other part by subtraction. 0.5 subtract 0.427, and then we get to know this region must be 0.073. Okay, I'm going to answer here. The area is going to be 0.073, which is right here. Okay, this region, as we just answered, as 0.073. Okay, let's look at the next one. Next one is slightly different. We got to see two z-scores, but none of them is a 0. And these two z-scores happen to be, they are both positive. 0.8, if I put it here, 1.3 must be bigger. So we mark these two z-scores to locate the region where I need to find the area for. With each z-score, I can go to the table. Let's go to the table. Look up at 0.8 first. 0.8 is right here. The 8 value is right here as a 0.288. 0.288 should go in here. Remember, we said all the 8 values you find from the table will be between z equals 0 and a positive z. So when we use 1.3, go to the table, 1.3 is going to be right here. And the 8 value is 0.403. This 0.403 indicates the area between 0 and 1.3. Between 0 and 1.3 means this region should have the area of a 0.403. So therefore, the shaded region is going to be, we used the bigger area right here, subtract 0.288 and to get a shaded region. 0.403 minus 0.288, and that's going to be 0.115 as the area. So again, see the red marking? I have it right here. The red region right here. This with area 0.403, and this with the area of a 0.288. So can you see we actually know the bigger region? We know part of the bigger region. I can find the remainder, which will be right here, by subtraction, and as the difference. So that's the area of the blue shaded region. Okay, next one, let's look at this one. This asks you to find the area between these two z-scores and their two negative z-scores. It's actually quite similar to what we just did. If I mark negative 1.55 here, negative 1.85 must be there. It really doesn't matter where you locate them as long as you put them in the correct side. I know scale-wise this is not really quite right. Look-wise, it doesn't look quite right, but location in position of one number to the other, the relation is right. So I will go to the table to look up these two z-scores. Let's go to 1.55 first. 1.55 we see right here. I have a value 0.439. 0.439 means it's going to be the area in this region, 0.439. And then we're going to look at 0.185. When we go to 0.185, we see here. So with 1.85, I have a value as a 0.468. 0.468 should be here. .468. So again, this is saying the area of the blue, just a blue outlined region is 0.468, and this region right here is 0.439. How do you find the shaded region? We say we take the difference between the bigger one, 468, subtract the smaller one, 0.439, and as 0.029, and that is the area of the shaded region.